Hello and welcome back to the channel Understanding.Concepts.Of.Physics. Hope you have subscribed my channel and you have been following me and my videos regularly. Today we are going to discuss about isothermal process. So we are on a series of doing types of process in which we have done reversible and irreversible processes in the previous class. And in this reversible and irreversible we had done in the previous class. We had seen the PV diagram as well, and today we are going to do something called as isothermal process. Isothermal process is a process in which the temperature is kept constant. So if the temperature of a system is kept constant, then the process is called as an isothermal process. So it's a very simple process in which you just keep the temperature constant and you let other things change. So that process is called as an isothermal process. So this becomes the definition: the process in which the temperature is kept constant is called as an isothermal process. Then we come to, okay, so if the temperature is kept constant, that means dt, that is the change in temperature. This is what is called as a change in temperature. Now if the temperature is constant, if something is constant, that means it is not changing. So if temperature is kept constant, that means the change in temperature is 0. And in the previous videos we have seen that the internal energy of the system is basically its kinetic energy in case of gases, and this kinetic energy depends on CRMS, that is the velocity. Root means square velocity, and this velocity depends on temperature, square root of temperature. So if temperature is constant, if there is no change in temperature, then the internal energy will also remain constant, and if the internal energy remains constant, that means the change in internal energy will also be 0. So that's what we have written, the change in internal energy. This can be asked in MCQs, that in a thermodynamic process, in a isothermal process, the change in internal energy is how much. Now let us find out quickly the work done in a isothermal process. So I'm applying the first law of thermodynamics. So here we again start with a small series of 4 special processes. One would be isothermal, the other would be isobaric, isochoric, and we also have adiabatic process, and we'll be finding out work done in each cases. So let's begin with this. The process would remain same. By first law of thermodynamics, we know that dq is equal to du plus dw. Now to understand first law of thermodynamics, kindly go back to the videos and have a look at other videos in the playlist named thermodynamics. Okay, so in this law, first law of thermodynamics, dw is the work done, dq is the energy, and du is the internal energy. Now because du is equal to 0, that means in an isothermal process du is equal to 0. I just explained this to you. So I can just cut this off. and dq would be equal to 0. Okay, so dq would be equal to du plus dw. So du is 0. I'm just sorry, my alarm rang. dq is equal to dw. We have seen that du is going to 0. Now also we have understood that work done is basically equal to change in pressure into change in volume. So I've just replaced dw as pdv, and we know that ideal gas equation says PV is equal to nRT. So mind you, we are finding out work done in isothermal process. So PV is equal to nRT. So if V goes on the other side, I have P is equal to nRT by V. So I'll put this value directly over here. So dq is equal to P and PdV, which is changing to nRT by V. So my equation will turn up like this: dq is equal to dw is equal to nRT by V into dV. Now what I am with is an equation, or different with a small equation. If I integrate this, I'll get the full amount of work done. So remember one thing, that if you have a small element of something, and if you integrate, you will get the full amount of that thing. So if I have a small work done, then definitely I can integrate this and I get the full work done. So let's integrate this. Now the basic mathematics for integration you should be knowing here. Integration of dw, integration of nRT by v. So the work done could be 0, could be w, and the initial volume is vi and the final volume is vf. Now let's integrate. Now integration of dx is x, so integration of dw is w, and nRT is a constant, so we'll move this nRT outside, so nRT goes outside. What remains is only dv upon v. So now integration of dw is w, and integration of 1 upon x dx is log x. Now this is called as the natural log. It's basically like ln stands for natural log, and natural log is having a base of e, and e stands for an exponential constant whose value is fixed. E value is 2.718182, and it keeps on going. Like how in mathematics you have a very special place for pi ka value is 3.14, and it keeps on going. So as pi has a special value, e also has its own special value and own special place. So just do not get confused with log and ln. When we say ln, we say it's a natural log and its base is e. So integration of 1 upon v is log v in bracket vi to vf. So upper limit and lower limit goes to the right. Then we get rid of these limits, upper limit and lower limit. So wherever there is a variable, you put an upper limit, minus wherever there is a variable, you put a lower limit. So w, in place of w you have a w, minus in place of w you have a 0, so w minus 0. nRT as it is, it was, and wherever there was a v, there was vf, and minus upper limit minus lower limit. So wherever there is v, there is vi. So upper limit minus lower limit. Mind you, here keep the functions. Do not do it like this, log of vf minus vi. This would be a wrong step in math. So this is what integration looks like. Now w minus 0 is w, nRT as it is, and we know the property of log, that log of a upon b is equal to log of a minus log of b. So we can just invert this thing. So log of vf, that is final minus initial, would be final upon initial. So this is a property of log which we have used in a reverse manner. Now this is a valid equation. I mean, this is most of the times we have been using, but in case if we have the values of pressure and not of volume, then how do we do it? So we'll just use this PV is equal to nRT, and PV is equal to nRT. So PI VI is equal to PF VF. PI VI is equal to PF VF. Now just keep the VF on one side and pull this VI on the other side. So VF upon VI, and this PF on the other side, so I get PI upon PF. So wherever there is a VF upon VI, I can always write as PI upon PF. So I am seeing that I can put this value over here. So W is equal to nRT log of PI upon PF. Now quickly turn to the PV graph. The PV graph for a isothermal process looks something like this. On the y-axis it's pressure, on the x-axis it's volume. Volume is SI unit is meter cube. The pressure SI unit is Newton per meter square, as I have mentioned. These units becomes irrelevant. The nature of the graph is most important. So let's say A is our initial state and B is our final state. So the volume is VI, initial volume, PI is initial pressure, final volume, final pressure is for B. So the graph goes into a curve. The graph goes into a curve. Now why does this happen? Because PV is equal to nRT. So I can say PV is equal to, this thing is a constant, because n is a constant, r is a constant, and temperature is also a constant in an isothermal process. So I get P is equal to K by V. Now any inverse function will have a graph which is decreasing. So we have just mentioned that. And lastly, PV graph of an isothermal process is also called as an isotherm. So PV graph is also called as an isotherm. Now the one more thing I would like to add over here, just in case if your board demands or if you are going for a competitive exam, this is at one temperature constant, like this could be at 300 Kelvin. But let's say, suppose if you have another temperature and let's say this was at 300, now you are at 400 Kelvin, so temperature is being constant, then the graph will shift like this upward, and then the third temperature would be like this, and the fourth temperature would be this. All these graphs are called as an isotherm. So this is second temperature, this is the third temperature, this is the fourth temperature. So this is what kind of an isothermal process concept is. So that's all for today. Thank you so much for watching. In case if you have been so long, thank you so much for subscribing, and keep following the videos. Bye.